Hello, everyone, and welcome to today's presentation on Test Anytime, Anywhere with Service Virtualization. My name is Jamie, and I'd like to welcome you to today's session. We are going to get started at the top of the hour, so we'll let people join for a few more minutes here, and then we'll dive right in. In the meantime, if you're feeling chatty, you got your coffee this morning, feel free to say hello to us in the chat. Feel free to pop in, where you're dialing in from today. I'm over here in Monrovia, California, which is where Parasoft is headquartered. And then we've got my colleague on the line, Grigori. You're over in San Diego, correct, Grigori?
That's right, sunny San Diego, as you can see from my totally realistic background.
Very serene, that background, though.
Right, right. It's sunset here around 9 a.m.
It is giving those beach vibes, though. All right, everybody, if you're just joining, thank you for joining our session today on Test Anytime, Anywhere with Service Virtualization. My name is Jamie. I'm going to be one of the co-hosts today. We're going to get started at the top of the hour, so we're just giving everybody a little bit more time to join the session. So just hold on tight. Again, if you'd like to say hello, feel free to pop into the chat, a quick hi with where you're dialing in from today.
Yeah, it's good to see some folks joining here.
Yeah, everyone's trickling in. All right, well, it is top of the hour, so I think at this point we can probably get started. Um, so again, everybody, welcome to today's presentation and thank you for joining our webinar. My name is Jamie Motherall. I'm a functional testing specialist and a product marketing manager here at Parasoft. And on the line with us, we have one of my colleagues, Grigori Trofimov. Grigori, you want to say hi?
Hi, my name is Grigori Trofimov. I'm a senior solutions engineer here at Parasoft, and yeah, looking forward to today's webinar to talk about how we can test anytime, anywhere with the right service virtualization solution.
Yeah, we've got a great presentation planned for everyone. We're going to be discussing some of the benefits and applications of service virtualization, and then what to look for in a testing solution. Now, some quick housekeeping before we dive in. If your view of the slides today appears a little blurry, please be sure to adjust the video resolution in your GoToWebinar browser. It helps if you also maximize the presentation to full screen. Now, if you do have any questions, any issues with using the GoToWebinar controls, feel free to go ahead and pop them into the Q&A box, and we'll try to reach on out to assist you during the presentation. We have a lot to cover today, so we're going to start with a discussion around the need for service virtualization and how it helps with continuous testing. From there, we'll share one of our customer stories. So we'll walk you through how Cox Automotive and Dealertrack were able to leverage service virtualization to solve some real and costly challenges they were facing. From there, we'll discuss features and capabilities to look for in service virtualization solutions. And we're going to break it down by touching on 4 critical capabilities to easily help you to scale the adoption of service virtualization and help you to maximize your value or your ROI. From there, we'll wrap up with a little guidance on how you can get started with service virtualization today. Now, keep in mind, we have allocated some time at the end of today's presentation for questions, but we will be monitoring the QA box throughout the webinar. And if a question comes up, time is allowing, and it makes sense for us to address that question in the context of what we're discussing at that time, we'll try to work in that question. So again, feel free to pop your questions into the QA box at any time. At the end, we'll go over all the questions as well. All right, so let's dive in. Now, there are many different applications of service virtualization. So let's explore some of those because the different uses are going to be different based on the industries or different phases of the software lifecycle. For instance, we see service virtualization used in development for prototyping and early development stages of an application with personal developer sandboxes. We are also seeing it on the operation side of things. So that's with like sales demo environments, training environments, and customer specific sandboxes for customer integrations. Today's presentation, though, is really about testing and test automation. So we're going to focus most of our time today discussing how service virtualization is used in quality assurance to help to stabilize test environments, tackle edge cases, or relieve test data constraints. Now, as a software testing solution vendor, we've been in this industry for 35 years. And here at Parasoft, we obviously think about software testing a lot. One of the analogies we commonly use when discussing service virtualization is that of a faucet. If you want to check if the faucet is working as expected, you turn it on and off. Water either comes out or it doesn't. And you might listen to the pipes to make sure there isn't nothing dripping, but you really can't do that without there being water in the house already. And it's not just water, but you have to have all the plumbing, the pipes, the water heater, and all the little pieces that go into a house's plumbing system. Even the bad stuff still needs to be checked before you can safely sleep at night, knowing that there isn't going to be a damaging water leak. Software testing is a lot like that. An API on its own doesn't do a whole lot other than return a response. But the content of those responses is really a result of carefully orchestrated interactions between multiple internal and external services, databases, legacy systems, mainframes, etc. Testing one API really requires standing up the whole system. And that can be a very expensive venture if all you're really looking to do is properly validate the functionality of that one thing, the faucet. You don't need to build the whole house to validate the faucet. You can use service virtualization to simulate water flowing through the faucet or to simulate a bathtub and make sure you have enough hot water to fill up that bathtub, for example. So, Grigori, how does this translate into software testing? You want to take it away for us?
Absolutely, Jamie. So, you know, the 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 beginning of our challenge really comes from the complexity of our application, right? And you might think, okay, well, it's a front end, it's it's some APIs, it's a back end system, right? But to test all of those different components and to do that effectively and efficiently, right, and in a way that scales, you have to think about, how much testing you're doing for each component, at what scope and at what level you're doing that type of testing. So for your UI components, for your mobile front end, or for your web UI, right, you're going to have some Appium scripts, maybe Selenium scripts, maybe even manual testing, right? A lot of times is focused on that human interaction component, but then all your non-human interaction and integration components like APIs and backend systems and all of those other different types of channels, whatever your application may be doing, need their own tests as well, right? So to fully test those user stories and to fully test the functionality of your application in an efficient and scalable way, you need a solution that can do all of those things and can do those things end to end. And once you've established uh, a good test automation strategy, right, something that you can do as a part of your shift left process, something that you can implement as a part of your test automation or your software pipeline. You may also augment those tests with non-functional testing practices like performance testing, API security testing, right? That's great, but that really just leads you to a new type of problem, which is the housing, right? And to take that faucet analogy, in the context of our application, right? It's going to be all those back-end services, third-party services, dependencies, um, components in the overall system that may be developed by different teams. Are they going to be available for you to actually run your tests continuously? And when we say continuously, right, not just to sort of prepare the test environment for test automation at the end of a sprint or at the end of a cycle, but really to be able to do that anytime new code is checked in, anytime you're enhancing an application or implementing new functionality and working on those features and user stories. And so the types of challenges that can be common here, obviously, services, right, that are, third-party services, payment processing services, credit check type services, VIN number validation services, those kinds of components that typically, there exists a solution out there that will typically provide, a sandbox for you. But is that sandbox enough? Is that sandbox sufficient for everybody to be able to do their testing? Does everybody have to share a single sandbox, right? Where uh, that, you know, some teams are going to have a certain window of time to test, other teams are going to have going to have to wait, right, and which results in downtime. That's a common challenge for continuous test automation. Now, if you've resolved that, and let's say you've containerized your dependencies and various components to your application integrates with, and you can stand those up, anytime, anywhere. Well, can you control the behavior? Can you control the test data? Can you simulate various edge conditions, right, that you might need to test for? Is that data synchronized with the test data that you're using for your test automation? More often than not, that is not the case. And so the ability to control the behavior of your dependent systems becomes a challenge. In many distributed systems, right, we have various, architecture strategies. Very, very common one, of course, is microservices. And so if your organization is doing microservices across the board, chances are different teams are developing different services, and you're relying on those teams to deliver the most recent and the most current version of those services in order to do your end-to-end testing. If that type of cadence is not across the board, if you don't have access to those services, obviously that's a roadblock, and that's going to result in downtime associated with test automation. And of course, when you think about scaling your test automation practice and doing things like performance testing, you have to think about, whether or not your test environment is actually ready for performance testing. Does it have a sufficient amount of data? Does it have realistic latency behavior? Does it have realistic delays? Is it going to scale when you actually want to simulate load that is reflective of realistic load, and you don't have to compromise on that, and do performance testing with smaller number of transactions per second? These are the challenges that service virtualization aims to resolve by allowing you to stand up virtual instances of those types of dependencies, allowing you to customize the way your application behaves. We're going to talk about the functionality that goes into a mature service virtualization solution that also allows you to do things like scale your virtual assets and give them realistic performance characteristics and realistic behavior characteristics. The other thing to consider, right, is when you actually scale the practice of service virtualization, whether or not you can capture all your virtual services and collect your virtual services in a way that you can still do ad hoc testing or deploy a predefined state of your environment as a part of your CI/CD process. Uh, we call this the environment-based approach to testing. So rather than dealing with each individual service one by one, once you have a certain practice of developing virtual services, to be able to collect them and assign a state to each asset, assign a state to each service. Some of your services may be real endpoints, some of your services may be virtual endpoints, some of them might be in a sort of a hybrid state where there's a failover where if one is not available, it fails over to the other, right? To be able to collect that, to be able to assign a state, define it, and deploy that consistently as a part of your regression suite execution, to know that you have a consistent environment that is going to work, that has the right data, where your tests are going to behave in a stable manner with a stable test environment. That is to develop an environment-based approach to test automation. Jamie, how do we see this implemented across our customers?
Uh, I'm happy to dive into it. First off, thank you for breaking that down for us as far as how service virtualization fits into the testing process. Now, the I want to talk a little bit about Cox Automotive and DealerTrack because they really describe their challenge as the perfect storm. You see, the big challenge for Cox Automotive and DealerTrack in particular is the sheer scale of services that they offer. DealerTrack services the entire car dealership network in North America, from the time a customer enters a dealership, sits down with a salesperson, to financing, contracting, signing, registration, titling, all the way to the delivery of the vehicle. So they had a huge number of services at play. And the dependencies inherent in such a system, complex system, means that even a small change would have a significant ripple effect across the entire system. So juggling all of these dependencies that were consistently going through application change was impacting their ability to test, resulting in defects escaping into production and impacting their user experiences. So this is really where Parasoft came in. They approached Parasoft where they reached on out to us, requested a demonstration, met with our technical team, and really outlined the problem that they were having with us and said, at the end of the day, with these environmental issues, our goal is to overcome them, increase our testing so that we can measure our success by reducing escape defects to less than 5%. So this was their overall goal. So let's talk a little bit about the approach that they took to achieve this. First off, we focused on helping them to increase their testing productivity by isolating their applications under test from dependencies, and that was through the creation of virtual services or simulations of dependencies using service virtualization. This allowed them to have a lot more control over their dependencies and enabled them to increase their testing as they were no longer limited by the availability constraints of their environment. Now, the next step was to enable their test automation, so that it could run anytime with automatic failover. When a live service would go down or become unstable, Parasoft CTP, which is our platform for test orchestration and environment management, would automatically switch their tests to run against that virtual service when the live service went down or became unstable. This allowed them to run their test automation with fewer disruptions. And then finally, another goal that they had was to increase system availability and reduce testing wait times due to dependency downtimes. So when a dependency would go down, this would interrupt the testing team's ability to test and execute their tests when they wanted to. So they weren't able to get that testing feedback when they needed it, because of this dependency downtime. So they really wanted to reduce that. So what was the outcome? By stabilizing their environment, they were able to increase their testing and their test thoroughness. They were able to reach their goal to reduce escape defects to less than 5%. With that automated failover from testing against a live service to a virtual service, they were able to increase their system availability for testing to 99.97%. Extremely powerful. And then as they scaled the use of service virtualization, they were also able to reduce their testing wait times or downtimes as their team had access to virtual test environments and was no longer blocked by the instability or inaccessibility of their environment dependencies. This enabled them to reduce testing downtimes by more than 50%. Now, Grigori, I know you've worked with a lot of our service virtualization customers. I believe you've worked with Cox Automotive as well. Is there anything you want to add to this?
It's such an interesting use case. One of the unique things about uh, the US, right, is that every state actually gets to define the way their DMV operates, right? And so for an organization that actually integrates with a lot of these DMVs, that means integrating with very unique individual processes, right? So states get to define, how they issue licenses, how they process certain insurance, how they process paperwork, how they store it in many ways, and that actually leads to all these different states having different technologies as it pertains to their, automated DMV functions. And you're going to have some states, right, that use REST and JSON and automate everything and really kind of ahead of the times. Then you're going to have some that are kind of in the middle there, right? And maybe they use event-driven architectures, some that use legacy systems, and then you have some states that still do a lot of this work manually, right? So for this organization, the requirement to really be able to support all these different workflows, protocols, message formats, right? That was a requirement from the onset, right? And I'm actually, going to talk about here about the sort of the growth aspect. Well, we'll talk about the growth aspect and the journey there. But for this organization, that was, a core requirement to be able to do a lot of things from the onset.
Mhm. So let's switch gears here a little bit. We're going to start to dig into what to look for in a service virtualization solution and how to determine what is the right fit for you. Now, of course, service virtualization has been around for a while, and there are a number of different solutions out there for you to look at. We typically see them fall into two categories. So you have your lightweight tools. Those tend to be open source frameworks like Traffic Parrot or WireMock. Some people even potentially use tools like Mockito for code-driven frameworks. And they're great to get started with because obviously you've got ease of access. It's open source. You can just kind of plug in and go and play. And they'll cover simple use cases like HTTP-based transactions, for example. And you can also customize these lightweight solutions to meet your needs a little bit. Now, these tools are free in the short term, but in the long term, the trouble with these tools starts to present itself with challenges that arise in maintaining or potentially expanding usage to support large scale deployments. If you think about it, the support internally these tools will need because they don't have vendor support is going to be vast. So as you try to scale, it can often turn into a costly headache. These tools can also be limited in the scope of use cases they support. And that lack of technical vendor support means that often vast amounts of internal customizations are going to need to be made to support larger and growing requirements of enterprise deployments, which means that your team internally has to then also maintain all of those internal customizations. And that's where there's a lot of cost that tends to add up. Now, this is where the other category, enterprise tools, comes into play. And this is obviously where Parasoft fits. One of our primary advantages here is you're going to get vendor supported technology, which means if there's a problem, you have someone to pick up the phone and talk to. Enterprise tools also usually support a much wider range of use cases. So you're going to have comprehensive support of different protocols, meaning that you can support use cases beyond that simple HTTP RESTful calls. This means it gives you the ability to really leverage service virtualization as a team and at more of an organizational level. So you've got these two different categories, and really what you need is the ability to balance both. Now, before we move on, let's get Grigori's perspective here. As a solution engineer at Parasoft, you work with our customers a lot. What do you see really that works, that doesn't work, that tends to present challenges in the long run?
Well, why do you need the best of both worlds, right? It's really because when you think about service virtualization, the service virtualization journey, right? When you initially start with your service virtualization use case, a lot of times we focus on the team, right? And what are our team's needs? Now, in the example that we provided earlier, the needs were actually pretty broad right out of the box. But a lot of times, service virtualization, the need for service virtualization comes from a specific use case and something that, well, we just need to virtualize this one service, or we just need to virtualize a couple of services here. And you can, because you're so early in those stages, and because your challenges are so localized to your team, you know, you can take some risks, right, in terms of trying out different solutions, trying out different things. The return on that time isn't going to be as significant because you're going to address your specific needs, but it's not like you're going to be able to. It's not like you're going to take the solution and you going to scale it immediately to everyone in the company, to everyone in the organization. So later on, when you do find success and all of a sudden you're demonstrating, hey, we're actually able to do this thing here, that's kind of where the growth portion of your journey comes in, right? Year one, year two, potentially, where all of a sudden, other teams are like, well, can we also leverage this capability? Well, actually, our use case is a little bit different here, but that's okay. Maybe we can just do some custom work here, maybe some custom development, and really extend what you're doing here for our use case. Then year two, year three comes along. All of a sudden, this is a very successful project. Um, Other teams are looking at you, multiple teams are looking at you to say, hey, can you adopt this to, at the enterprise level? We also actually have a COE here, and we want to implement some governance, and we also want to implement uh, some processes around validating and ensuring that only the proper virtual services make it into, I'm using air quotes here, production. And we also want to do performance testing. So the risk here is actually now high, because all of a sudden this solution that you selected for, a very specific use case, the enterprise is relying on what can very much be a critical piece of infrastructure for a lot of test automation across the board. The value here is tremendous, right? To be able to do the type of testing that allows you to, increase your transactions per second by, 10 or 100 transactions, a magnitude of 10 or 100 transactions per second, to be able to do 1,000, 5,000 transactions per second. That's huge, to be able to enable multiple teams to do test automation in their CI/CD pipelines. That's huge. However, if your solution can't scale to that, and now all of a sudden you're looking at 3 years of growth, and you're finding out now that you're not able to do these things, or that you're not able to support a certain type of protocol, or you're not able to support a certain type of process, um, well, not only do you have to go back and look at one of those mature enterprise ready solutions, and probably the cost of that solution is going to be significantly higher than what you started with, but you also have to look at the rework that now you have to do, and you have to redevelop a lot of those services under a new solution. So choosing the right solution early on um, is critical when you consider this journey, and when you consider all these stages of growth. So you know, when we think about, okay, well, how do I evaluate a solution, right? How do I know that this solution is going to help me scale? How do I know this solution is going to help me maximize the value? We break this down into, 5 primary categories. Ease of use and capability. Again, this is going to be critical early on when you're starting out, right? Being able to stand up virtual assets quickly without a lot of scripting, right? Or any scripting, hopefully in many cases. Support for optimized workflow and supported technologies. So during the growth stages, right, year one, year two, ensuring that you can actually extend the capability of your service virtualization practice to other teams and to critical operations aspects of your organization. And then automation and maintenance and management of those assets. That's when you're looking at service virtualization at scale. And different industries, right? But the different types of enterprises, different teams are going to have different requirements. So it's important to sort of inventory, what am I doing? What is my organization doing? If I'm a financial organization, right, you're going to maybe look at things like stateful virtualization, right, and ensuring that that you can create, read, update, delete data, and that those changes in the data can be reflected in downstream API calls with your virtual services. You may also look at various protocol support, like TCP, for example. There's a lot of custom TCP-based message formats and customization options that are required in order to virtualize certain types of payment processing services and components. Support for things like Fix, Swift, etc. Right? Different types of message formats. On the other hand, if you're a telecommunications organization, you might be more concerned with things like big data, right, and streaming data. So event-driven architectures and things like Kafka, for example, Avro, um, uh, schema registries, right? Those types of things need to be supported in order for you to do a service virtualization with external dependencies. And then in the healthcare industry, right, you may be more concerned about data security, right, and things like being able to obfuscate data or synthesize and generate new data based on a specific requirements, so that you don't have a production data escaping into your test environments. Again, you have to inventory what is your organization doing, what are the requirements of the organization. Chances are you might see at what all the individual teams are doing, and you'll see, well, we actually need a solution that checks all the boxes.
Mhm.
Jamie?
And it's a lot of boxes. So really, I think at the end of the day, what we're trying to say is you need to think not only about your current existing needs when it comes down to a service virtualization solution, but you also need to look at where you plan to be in 5 years. What is, if this is something where at the end of the day, you do want to scale it at an organizational level, you need to look beyond what your current needs are and think about the future needs as well. Now, what we're going to do for the rest of today's presentation is break this down into 4 key kinds of things, key areas that are all about maximizing the value or the ROI of your service virtualization solution. So we're going to go ahead and talk about how to create the virtual assets or simulations in the first place, because obviously it's hard to scale if the solution does not provide you an easy way to start creating these virtual services. We're going to talk a little bit about breadth of technology. Grigori already went into this a little bit, but we'll break it down in more detail. We'll talk about the architecture for deployment, also how to utilize and manage those virtual services. And then we'll start talking about change management, because your APIs, once they're done, they don't just remain static. New elements get added, new services get added, and you want to be able to really understand how can I very quickly manage those changes? Otherwise, your service virtualization strategy is not going to be easy to scale. So, Grigori, why don't you take us through it?
Absolutely. Rapid virtual service creation. When you think about this, again, this is when you have kind of specific requirements, right? Specific needs. You're developing an application, you're testing an application, and it's not necessarily that you're thinking about this complete unstable test environment, but there are some services, right, that are not consistently available to develop against or to test against. And so you're looking for solutions to be able to stand up a virtual asset quickly. So some of the key capabilities there that you're looking for is, and this is probably the most common one, is the ability to import definition files, right? Chances are your dev team or your partners, right, they have some sort of spec, they have some sort of documentation associated with how your integrated API is supposed to work. And typically, the best practice to do that is definition files like Swagger files, WSDLs, Open API specs. And so a service virtualization solution, a mature service virtualization solution, should be able to easily import those types of definition files. A lot of times today, those types of definition files will also have examples in the payloads, right, for the API schemas. So not only are you getting all the resources documented in this definition file, but you're actually getting some sample data that is coming directly from the developers. So you have some intent on how that virtual service is supposed to behave to mimic the real service as defined, as designed by the developer. Another common strategy for virtualizing services quickly is to record traffic, right? So you get a lot upfront with recorded traffic. You get the data from your tests. Whether it's some user IDs or some account numbers or zip codes or addresses and things like that, right? You'll find that in the traffic. You'll also get logic on inferred from the traffic on how this real service is intended to behave, and the sequence of API calls that is actually made in order for this end-to-end test to go through. So if a service virtualization solution can actually take that traffic and infer from the traffic not only the data, right, and all everything that you're using to drive your tests, but also infer some of the intelligence, right, and the conditions and look at the traffic and say, okay, well, I see this zip code here, and I see this response to the zip code. That means this is how the virtual service is supposed to behave. On the other hand, when I see, this user ID and this particular status or approval status or something like that, I actually need to return, this type of 404 error, and it's going to have the following error message, right? Being able to look at that traffic, being able to automatically infer those conditions and set those virtual services up for you without scripting, without having to do, training on the domain logic of your service is really the main and one of the most critical capabilities in terms of getting service virtualization into your team and getting immediate return on your work when implementing service virtualization. Some solutions do set themselves apart with certain capabilities in terms of being able to do that. From Parasoft's perspective, one of the things that we've introduced in our recent releases is called Virtualized Learning Mode. This enables teams to define a live endpoint, right? Let's say this endpoint, this endpoint goes down from time to time. It's not a very stable component within the test environment. You can enable learning mode. And as you're running tests against your live endpoint, Parasoft is going to do the work of creating a sort of a digital clone, right, or a twin for that live endpoint, so that when inevitably that live endpoint does go down and is not available for some reason, you have something to fail over to that is going to have all the history, all the same behaviors of your live endpoint. And you can obviously extend your virtual endpoint to have more data and to augment it with additional logic and additional capabilities. But the key thing here is, again, it's a low barrier of entry for service virtualization. It's something that you don't have to go and train a whole team on how to do this, on all the intricacies of service virtualization. You can, introduce service virtualization, say, give me your live endpoint. Now you have a virtual endpoint to fall back to when the live endpoint is unavailable. Jamie?
Mhm. I really love Parasoft's virtualized learning mode. I know we just talked about this a little bit, and we're going to go into change management shortly and cover it in more detail. But one aspect I love about this is because learning mode is continuously recording traffic between endpoints, it is consistently automatically updating any virtual services that you have, so it's keeping those virtual services always up to date and relieving that maintenance burden on the team as well, which is so powerful for scaling. Again, we'll go into more detail on change management here shortly, but let's switch gears up. We're going to dive deeper into our next subject, which is looking at breadth of technology. So, what is breadth of technology? Go ahead, Grigori. Walk us through it.
Yeah, absolutely. you know, a lot of times we think about deploying a virtual service over HTTP and developing our virtual services over HTTP, maybe their REST endpoints, maybe their legacy SOAP endpoints. But what happens if you need to redeploy the same service or you need to redeploy the same functionality over a different protocol, like an MQ protocol, right? Will you need to recreate that virtual service from scratch and redefine all those deployment configurations? What happens when you're going outside of typical JSON XML payloads? Are you going to be able to support more legacy systems like say using copybook or something like that? We talked about EDI formats. A lot of times you uncover additional value from service virtualization when you start digging into those types of use cases and those types of protocols, right? You're obviously going to have your low-hanging fruit with REST and JSON, but there's going to be additional value there when you start to extend beyond that and understanding what level of support you have for those other types of message protocols and message formats. And again, to be able to do that without significant rework or really any rework means you're working with a mature service virtualization solution. Additionally, there's different types of applications out there, and that's definitely something that's constantly evolving. So we look at things like IoT and microservices and the different types of protocols that and requirements that come with supporting those types of applications. There's a lot of conversation. There's a lot of development in the space of software driven vehicles, right? So maybe there's a use case where you're looking to simulate the behavior of a certain ECU, and what type of protocol you need to support there. Is that something that your service virtualization solution is exploring? Is that something that you can do without doing custom development, without building your own extensions and building your own wrappers for something that other teams are using today? And then finally, data. Being able to data drive your virtual services with, static data is pretty straightforward. Frankly, parameterizing virtual services with a CSV file or an Excel spreadsheet is also something that's fairly common. However, maybe your test data is actually stored in a dedicated test data database, and is that database supported? Are you able to hook into that database, pull that data directly into your virtual service, and data drive your virtual service in that regard? What happens when that data changes? Do you have to redeploy your virtual service, or are your virtual assets, are the conditions and the logic embedded into that virtual service, do they support dynamically updated data in your test data database? Those are questions that you do need to ask yourself when you inventory your organization and your teams and what they're doing from a perspective of service virtualization. And this is a lot of times what we talk about when we talk about breadth of capability. The reality is there's a cost associated with implementing all these different types of technologies, and that cost could be a matter of rework, right? Again, if you're unable to easily transfer the business logic of a virtual service and the deployment configuration of a virtual service into a different type of protocol or a different type of message format or a different type of data store, right? If you have to do significant rework, there's cost associated with the time that it takes, and there's cost that is associated with the domain expertise associated with those types of technologies. Your service virtualization should be able to abstract those things out into a no-code type of approach, no-code type of solution, where you can simply, select, okay, now go to Kafka instead of, RabbitMQ, or now go to, now present this data in XML format instead of a JSON format, but use the same data. That kind of decoupling, that kind of design embedded into your solution is going to ensure that all these different use cases across all the different teams are supported when you're implementing your service virtualization solution at scale.
All right, so now let's dive into broadly accessible architecture. So that means, you had a problem, we simulated some service. Now, what do you do with it? How do you effectively leverage that virtual service with your test cases and relevant test data in automation?
Yes, Jamie. So, this is when we're talking about year 2, year 3 of your service virtualization journey, and when you're moving further down, that growth of your service virtualization adoption. Well, again, people see the success, right? People see success, people notice, and it's now kind of a matter of the center of excellence that wants to sort of implement a formalized process and a formalized practice across the board, across the enterprise, to expose service virtualization capabilities and to maximize the benefits of service virtualization. So what does that mean? Well, you still need that powerful feature set, right? You still need the ability to develop even more customizable, even more robust virtual services, cover more edge cases, and really drill into the business logic and the capabilities and the conditions of these services. From a more high-level perspective, right, you need a way to abide and define a quality process uh, on promoting virtual services, right? When you're just developing a virtual service for yourself and you're, validating something locally, well, if it doesn't behave exactly the way it needs to, that's okay, because you're not really impacting other teams. On the other hand, when you check that asset into source control, and that asset now goes into a centralized server that is used for functional testing for multiple teams, or into a performance testing server where it's utilized for performance testing, that virtual asset needs to be vetted. It needs to be vetted. It needs to conform to whatever quality standard you've defined, to ensure that it's it's, again, I'm using air quotes, production ready or production grade. And there needs to be a way to do that type of inventory, right? You need to be able to search through a catalog of virtual services, ensure you're not repeating work, you're not duplicating work. If there's something that you want to augment that some other team already did, you're able to pull it down without affecting what they're doing. So there has to be a level of roles and permissions and authentication and things like that that have to be supported for service virtualization to really be deployed at a enterprise level. So Parasoft is able to provide that through its continuous testing platform. There is a thin client interface to define systems, to have a nice graphical user interface to define a collection of services, assign states, assign environments, to have some level of segregation between data and virtual services. Different teams can deploy their own unique sandboxes that don't affect the work being done by other teams. All of this can be centralized and managed. There is an overview of the overall deployment of the overall orchestration patterns that you have, the types of services that you have deployed, and then we have support for things like authentication, various types of SSO, roles and user permissions and things like that, in order to ensure that only those who are intended to have access to certain things have access to those things, right? And there's no sort of spillover, there's no an infection of other teams' environments, other teams' service virtualization. And then when you think about performance testing, right, you also need to be able to track utilization and see how different assets are being utilized. What are the most popular assets? Which services are getting the most hits during performance testing? What type of response times are we averaging for each service, right? Do we need to go back? Do we need to up the resources a little bit for individual teams and let them know, hey, you're heavily utilizing these services. We need to ensure that you have appropriate resources assigned to ensure that those types of assets are meeting the demands of your testing. And all of that has to integrate with source control, obviously, right? So again, when you're developing assets, being able to version, being able to ensure that your virtual services are production ready when checking them into source control, right? That's a big part of a scaled, governed service virtualization workflow.
And last but not least, we're going to circle on back to change management, because at the end of the day, change management is really important to your test strategy. If you don't have a good strategy in place to keep these virtual services up to date, then at the end, your ability to scale is really going to be impacted. So let's break it down.
Absolutely. So, in the interest of time here, I'm going to tell a short story here, right? One of our customers, they well underway in their service virtualization journey. They have some partner APIs that they virtualized. The problem is partner APIs go through changes, right? And every now and then they would get an email saying, hey, we're updating our APIs. Here's the updated definition file. Unfortunately, we're actually not going to have a new version of this API deployed for another 2 to 6 weeks. So, don't use the old APIs, wait for the new APIs. So our customer, right, they need to update their tests. They need to make changes to their tests, and all they have is this definition file to go off of. Well, using Parasoft's Change Advisor capabilities, one of the things that they can actually do is they can compare version 1 and version 2 of their definition file. And what Parasoft will do is will actually create a mapping of the changes from version 1 to version 2, be that new elements in the schema, be that new resources, or maybe the name of some element changed. This mapping can be created, and not only can it be used to detect changes in your existing virtual services or even tests if you're using Parasoft testing tools, it can also generate a refactoring template. So you can actually refactor your virtual services based on the documented changes from version 1 to version 2. And now very quickly, without having to do sort of manual rework, they're able to update their virtualized partner APIs long before those APIs become available. And they're able to update their tests. So by the time the real partner APIs have come online. They already have their tests fully configured, fully ready to go, and ready to test against the real instance of those APIs. The change problem extends beyond beyond just defining the virtual service itself, right? We often have changes in the data as well. And more often than not, again, there's sort of a centralized database that stores all your test data. When changes occur or when a refresh of the test data needs to occur, that's usually a pretty cumbersome process, and it's not instantaneous either, right? So it requires multiple teams, it requires DBAs to clone some production data, subset it, scrub it, ensure that there's no private information, there's no PII that's escaping into the test data. And not only does that take time itself, well, chances are there's multiple teams using the same test data database. And so once that test data does become available, you either have a sort of a race to consume the data, especially the data that does get burned and not really available for reuse, or there is some sort of scheduled um, windows of when individual teams are allowed to do their testing. Service virtualization can mitigate this and can help you mitigate those changes, because in that downtime that's associated with the refresh of data, if you're using service virtualization, each team can deploy their own virtual services and augment and modify their data for those virtual services based on the type of test data that they're using, right? And again, each individual asset, each individual server can be segregated so that that data is not overlapping with other teams' test data. You can easily snapshot your data. You can refresh the data quickly and make it available for testing, so that by the time your test data database comes back online and is ready for your testing, you've already done a good amount of your testing. You've already been able to configure and ensure that your tests are ready to go. Or in certain cases, you may actually remove the need to rely on that test data, and you have a fully isolated testing practice for your application and for your dependencies.
All right, thanks, Grigori. Now that was a lot we covered, but some really powerful and useful tips on what to look for in a solution. So I just kind of want to bring it back for a second. We're going to talk about these four key areas and then dive into our recap. Rapid test creation. Basically, you want to enable the team as quickly as possible in creating those virtual assets. Breadth of technology, you want to think about not just your existing requirements, but where you want to be, in a couple years, and what would it take to scale it across the enterprise. Broadly accessible architecture, you need to have a way for you to orchestrate your virtual services with your test cases, with your test data, and that needs to be broadly accessible, easy way for everyone to access that. And then finally, change management. At the end of the day, what you really don't want to do is kind of create a can of worms for yourself where your teams are burdened by a lot of maintenance activities when it comes down to change management and updating these virtual services. So definitely look for those kind of key capabilities to help you to maximize your ROI and your value. So, stepping back all the way, let's recap why we're talking about this in the first place. We're doing this because your test environment is unstable, it's unavailable, or it's uncontrollable. And we can break it down into four key categories that we call the ABCs. So first off, availability. Are the dependencies you need available for testing purposes? Are they controlled by a third-party system? Maybe that system hasn't even been developed yet. Next, behavior. This isn't just about the functional or data behavior, but also the performance characteristics as well. The question is, can I simulate what should happen if my backend system responded very fast or very slow? Then cost. Virtual asset costs a lot less to deploy and manage than a back-end infrastructure does, especially when you're talking about third-party ecosystems where potentially you need to pay to have access. And then finally, data, test data. We just touched on this, but really many organizations struggle with test data in their test automation strategy. The ability to control your own test data as a team is very freeing, and you no longer have to worry about another team's modifications of the test data impacting your testing results. So, in summary, at a very high level, there are several things you need in every service virtualization tool. That's going to be the ease of use, optimizing workflows, supported technology, automation, management. But then you also need those four concepts we talked about to maximize your ROI and help you scale. So creation of speed of creation, breadth of technology, the architecture for access and deployment, and then change management and test data. And Parasoft Virtualized does check all of these boxes. It is a leader in the industry, so a leading technology for service virtualization, and it is that enterprise grade product. And I know not everyone's ready to dive straight into an enterprise grade product, which is why we also offer a free version of service virtualization that's designed to help teams get started with it. And then organically, as they get to that point that they want to scale to support enterprise or large scale deployments, they can then start to explore that enterprise solution. So we have here a link for you guys where you can go and access Parasoft Virtualized, the free edition right now. This will get you up and going with the desktop environment. It supports protocols that you'd expect in kind of that lightweight tool, such as HTTP-based protocols. And it really kind of sets you up because that framework allows you to eventually expand into the enterprise product. So great way to get started today. You can grab that URL there, or you can grab that QR code and just go ahead and sign up, download and get going. Now we went over a lot today. If you'd like to dive a little deeper, you want to maybe share some of this information with other team members, we've got there a white paper that we recommend. It's a guide on how to choose the right service virtualization solution. So it went through a lot of what we went through today, but it also kind of breaks it down in additional detail for you. So we are almost at the Q&A part. I did want to just point out, this was a presentation that's really at a high level what to look for in a tool. So of course, we didn't have enough time today for us to demonstrate our service virtualization solution. If you're ready to dive in, you go, I know what my needs are. I want to start talking to Parasoft about test strategy and how this can plug into my system. Go ahead and request a demo with us. Just like Cox Automotive did, our testing teams, our teams will reach on out to you, schedule a call to discuss what your challenges are, what your needs are, and then we'll provide you with a customized technical demonstration. So you can really see this tool in action and how it will map to your specific use cases and your requirements. Finally, before we dive into Q&A, are you going to Star West? Because I am. I'm going to be over at booth 30 at the Star West conference. So if you are at Star West, come on over, say hi. We can have a little chit chat, a little bit about your testing needs and test strategy, or just come on, say hi and let me know how you enjoyed this presentation today. Also, one of my colleagues, Renata Santillian, she's going to be doing a talk on the art of winning leadership support for web accessibility. So if you're there, I hope you can join us for it. We are going to do a fun raffle at the end, so come join us. And then if you are interested in Star West, you haven't bought your ticket yet, we do have right there the QR code that goes to the Star West site where you can select a ticket, and then there's a promo code so you can get $200 off your ticket to the Star West conference. Now, I do see a couple questions in the Q&A box, so let's take a moment to look through them. All right, so I see a question here. Do we support SAP IDOC?
That's a great question. So we do support some of the capabilities there. I believe actually we responded to the question there as well, and it really comes down to the use cases. So for whoever asked that question there, we're going to go ahead and reach out and ensure that your use cases are supported there. So
Mhm.
short answer, yes, but we're going to want to talk about specific requirements and specific use cases there to ensure that your use cases are supported.
Yep. Yeah, we'll have one of our team members follow on up with you to set up a quick call if you're ready to dive in. Okay. And then it looks here, let's see, how do you know if a service virtualization solution is ready for performance testing?
So I mean, that's a great question. There's a lot of solutions out there that kind of do various individual things. One thing to look for in a mature service virtualization solution that does do a lot of performance testing or can be utilized to performance testing is various benchmarking data, right? How does service virtualization scale with the complexity associated with your virtual services? You know, obviously a static virtual service that returns a 200 and some static data is going to be probably easy to scale, but what happens when your virtual service needs to update data across multiple data sets and other services need to pull data from those data sets and iterate over lists and arrays and things like that in order to get the right data? Well, a mature service virtualization solution will have looked at those things, will have looked at how to optimize your virtual services. So for example, Parasoft does provide a a performance testing white paper specifically to look at, you know, what are the requirements for doing performance testing as it pertains to the complexity of virtual services. So feel free to take a look at that on
Mhm.
the Parasoft website and request access to those resources.
Yeah, we can also include that in a follow-up email to everybody. We will be following up with a video of today's presentation so you can watch it on demand. And then we'll also include in that follow-up a link to that white paper on how to choose the right service virtualization for your organization. And then also a link to that case study on Cox Automotive in case anyone wants to dig a little bit deeper in there. Unfortunately, that's all the time we have today for questions. We really appreciate everybody's joining us today for this discussion. Again, you know, we're always here if you'd like to reach on out and just have a little discussion around test strategy, any challenges you're having, and how we can help you to overcome them. Again, thank you everybody for your time today. We really appreciate it. Have a good rest of your day, good rest of your week, a good Labor Day weekend coming up as well. All right, I think I'll end it there.
Thank you.
Bye. Bye, everybody.